something is really strange, and maybe it's just the way that physicists look at the world, but
Sure. I
and
mean,
not all physicists are like this, but
well, I think part of
that's
it
kind
is,
of emotionally like a tough thing, right? Like, wow, reality isn't real.
I mean, certainly you can feel many ways about it.
You are tuning in to the Multiversity, a podcast for higher dimensional education.
Join us as we explore philosophy, science, history, and the great unknown.
I think it'd be interesting to get into. I know that quantum physics implies some weirdness and maybe some weird. I don't know. The many worlds interpretation would imply some like weird exponential like universe growth, which would be difficult to deal with. But like for us individually, and maybe I'm just taking this to a really basic level where others don't want to go, but like this seems to have some weird like implications for the nature of the self and reality and ourselves, like emotionally. How do we handle showing up in the wave function multiple times? Like, what does that mean for who you are and what your decisions are and stuff like that? I know we can't answer those questions definitively, but I think that that's something interesting to explore, and any conversation about this definitely should be.
Yep.
I mean, that's pretty meaty to everybody, right?
Mm-hmm. Yeah, definitely. I think it's an interesting thing to talk about.
Yep. So, to quote someone who I cannot recall, it all adds up to normality. The fact that you appear in the wave function multiple times, well, there may be interesting things to think about that, but it doesn't change your experience of reality. There's no possibility of being simultaneously multiple of those terms that appear in the wave function. You're always just one. So.
I don't know, John. I think the implications do matter. I think the things that we believe about reality influence how we act in the world, the lives we lead, and how we relate to the reality around us. Like, I mean, one thing I've heard a lot is like a lot of people seem to associate quantum physics with postmodernism, which is this idea that like is this philosophy where everything is kind of it denies realism in a sense too, or like it kind of is skeptical of objective realism, and it's this idea that the person, like the experiencer and the historical context they come from, is inextricable from whatever thing they're observing. Or so it talks a lot about like it focuses a lot on language and how language shapes our thoughts and how language shapes our experience of reality and how our society and our history and our social upbringing influence our experience of reality. And so I've heard a lot of people like linking it with quantum physics.
Yeah, well, I took a short course in postmodernism in college for some inexplicable reason, but I think it's the postmodernists that associate postmodernism with quantum mechanics. It's not the quantum physicists.
Why do you think that
Yep.
physicists seem so chill about this?
I mean, maybe physicists are just chill people, but I don't know. Let's see. What do you really mean by that?
What I mean by that is, you guys are like studying these phenomena, which imply that reality isn't really real in the way that we think it is, and maybe we can think of it like the observation has, everything is happening at once, and when you look at it, then it's decided what happens. But everything is just probabilistic and there's not actually cause and effect. Or maybe reality is constantly branching into infinitely many realities. But however we look at it, something is really strange. And maybe it's just the way that physicists look at the world. But
Sure.
and not all physicists are like this. But that's
well, I think part of it
that's kind of emotionally like a tough thing, right? Like, wow, reality isn't real.
I mean,
Sort of.
certainly there. Certainly you can feel many ways about it. I think, the idea that the laws of physics disagree with our basic intuitions in sort of fundamental ways is not really a new idea. I mean, that idea, the idea probably goes back, at least to Newton. Nowadays, most people probably, I don't know what most people are like, but it's sort of easy these days to think you have some intuition about, theory of gravity, meaning the classical Newtonian theory of gravity, where you have different bodies and they exert some pull on each other. And that kind of makes sense, but that was an extremely uncomfortable idea, even for Newton.
Yeah, but it influenced history. I find it strange they're blasé about this, because if you look at Newtonian physics, they influenced history and they influenced intellectual thought and mainstream thought in profound ways that we still experience today.
Influenced religion.
Yeah, modernism.
Influenced the way that people interpret the meaning of life.
Yeah, exactly. Newtonian physics is deeply tied in with modernist thought, and now we have quantum physics, and it's tied in with postmodernist thought and tied in with all these other forms of thought that are dominant now in society. We're having a major philosophical paradigm change in society, and it's deeply woven in with quantum physics.
Well, I think, to the extent that these sorts of societal changes in the way things are thought about have been going on, I think, I don't think they're really due to the some discovery about what the laws of physics actually are. I think they're due to these sort of new conceptions about the way that things can possibly be. The way that societies behave, the way that peoples behave, the day-to-day experience of life, that has not changed as a result of the discovery of quantum mechanics.
It has changed enormously. Okay, look at Newtonian physics. If you look at discoveries in Newtonian physics, he basically demonstrated that the world around us functions like a machine that can be observed and predicted. And if you take the objects around you and you apply the right kind of math to them, you can predict them with extreme accuracy, and everything around you works like this magnificent clockwork, and that everything is connected in this cause and effect comprehensible way. That was a massive paradigm shift in society, and it affected the way that we think about ourselves. It affected the way that we educate children. It affected the way that we do medicine. It affected the way that we philosophize. If you look at 400 years of philosophy,
yeah, I see.
It's modernism. Modernism has massively influenced society. It's built the buildings around us, and now there's this new kind of physics that's much newer. So its effects are in their infancy compared to the effects of Newtonian physics, but they're already having a massive impact on the way people think, on the way people choose to live their lives. And it's a feedback loop. It's not just that the physics affects society, but they feed into each other.
Yeah, you're right. Such things happen. I guess what I'm trying to say is that, the laws of physics haven't changed during this time.
Right. The physical world that we're living in is still operating under the same laws as it was before. At least we assume. But I think that's a pretty fair assumption. Right.
We were quantum beings, based on the rules of quantum mechanics, even at the time of Newton.
But it's kind of like something like quantum physics is kind of like, okay, imagine this would be a physical discovery, a scientific discovery. We discover that there's imagine we discover that we're living in a simulation and there's a puppet master directing every way that we go. That would probably have big implications for how people live our lives and how people feel about everything. And I think that something like quantum physics, we don't really understand it so much, but something like discovering that reality is probabilistic, maybe, or the more we learn about it, the weirder it's going to get. I think it's going to have massive effects. It already makes me personally uncomfortable. Not that I was sitting super comfortably before, but it's, it's something. Does it hit you?
Well, you know, it's a mathematical theory that predicts everything that we've already observed. You know, it doesn't, you know, from my perspective, it doesn't. Nothing operationally has changed. It's not like I've learned about quantum mechanics, and now, you know, when I walk out my door in the morning, I'm like, well, maybe the sun won't be there, and that'll be interesting.
Right.
Like,
Well, no, but it's changed our level of knowledge. Like, you know, if I was, let's say, an educated person in the 1700s and I walked outside my door and I looked at the sun rising in the sky and someone riding by on their, I don't know if they had bicycles, but let's say it was the 1800s and they ride by on their bicycle and the building is standing and it's bricks, and I'm looking at that and I'm seeing a Newtonian world. It's like my level of knowledge, I'm like, it's all a great clockwork. The universe is one great machine where the process of cause and effect. And, you know, that's the way I'm seeing it. That's my level of knowledge. But now if I look out the door and I see the bicycle go by and I see the sun rising, well, the sun's complicated. Let's say I see the bicycle go by and I see the building standing and I see the ball rolling down the hill. I look at all that and I'm saying, like, they're all displaying classical behavior, but I know that they're only doing that because I'm happen to be sitting in this very specific corner of reality at this very specific size. And that if I go smaller, then everything becomes extremely weird.
Yeah, maybe everything's just some kind of a construction.
Well, yeah, but I think a lot of that is that, you know, we evolved to exist in this, you know, at this level of size and this level of time and this scale, you know, and so we're used to dealing with it, and so it makes sense to us. And when we try to zoom way out, we get general relativity, and we try to zoom in, we get quantum mechanics, and those are both kind of paradigms that people find very unintuitive because we don't exist, you know, on those, you know, massive time scales or tiny size scales. But yeah.
Not just unintuitive, but also it has some weird implications for things like free will. It has some weird implications for things like life and death. Okay, if you took the many worlds interpretation, is there a reality where you're still alive? Is every I don't know. Is everything possible that we can imagine, or are there still certain constrictions? Is it just that some things are extremely unlikely, but there's still like one or two universes where Abraham Lincoln is alive today?
Yeah, like if you almost get hit by a car or something, or you do something really risky, does it mean that like you lose a whole bunch of views, even if you survive?
I mean, you have to sort of believe that all of these events are somehow deriving from quantum superpositions, and you know, that idea.
Well, it's an interpretation. It's an interpretation. We're speaking speculatively. I think we understand that.
Sure. I think in some situations it's like quite clear that, you know, there are no quantum superpositions involved, and in other situations it's maybe not so clear.
Yeah, I understand that it's not clear for classically sized phenomenon whether we're causing wave function collapses by our everyday actions. I think we all understand that, but we're speaking speculatively.
And it probably seems unlikely that that's the case. But
Yeah, I mean,
I don't think it seems unlikely though. It seems like they have observed quantum phenomenon for classically sized objects.
Yeah, but like John said, you had to work really, really, really hard to keep it in a super state.
Well, but then, you know, I have to bring up Schrödinger's cat now. Like, you can set up a particle in a quantum superposition and do a measurement, which is a probabilistic measurement, and then, you know, the sort of violent analogy or violent thought experiment that follows is that you either kill a cat or not, depending on what you measured. Mm-hmm. And now, if you want to, if you believe this all plays out according to many worlds interpretation, then there's a term in the wave function where you did kill the cat, and there's a term in the wave function where you did not kill the cat.
And in the Copenhagen interpretation, the cat is both dead and alive at the same time until you look in the room.
Well, so then if you want to say there is collapse of the wave function, then we have to talk about where the collapse occurs. Yes, sort of the original point of the thought experiment is that if you isolate this cat and the machinery, now it's no longer you that's killing the cat, it's some machine that's killing the cat, or not killing the cat. but if you isolate that from everything else, then you have to sort of believe, according to the rules of quantum mechanics, that the cat still exists in the superposition until you interact with it.
Yeah, until you observe it.
Or you have to believe that there's something else causing the collapse of the wave function. Maybe wave functions just collapse when they get larger than, your thumb or something. That would be kind of ridiculous, and no one believes that. But
So I have just a really simple question for you, John.
Mm-hmm.
Do you believe in objective truth?
I think the question is too simple for me to give a meaningful answer. I don't know what you're really asking there.
Well, are there certain things that are objectively true? Like, does reality exist out there, or are we just like, could we be brains in a vat, or could we be in the matrix or in a simulation? Go for it.
Well, there's maybe a couple different things you brought up there, but could we be in a simulation? Sure, but so long as the rules of the simulation continue to be followed, there's no sort of meaning to that. If there's no way to get out of the simulation, then we may as well not be in a simulation. There's just nothing else. So there's sort of nothing to say about that. Now, if you're saying, we're in a simulation and there was a puppet master brought up earlier, and if we somehow discover the puppet master, then, well, it turns out, we were not in this perfect simulation. There was a way out of the simulation, and now we actually exist in this more complicated universe, and we have to rethink things.
Going back to Schrödinger's cat, if you actually set up that experiment correctly, to me, the interpretation that the cat is both dead and alive at the same time seems really unintuitive and really, really unreasonable, much more unreasonable than the many worlds interpretation. Is this idea that you could actually have a cat itself in a superposition commonly accepted, or how do you feel about it?
I don't want to speak for everybody. I don't know if I want to say that it's commonly accepted. I think, it's a thought experiment designed to get at exactly what's uncomfortable. But I do think that it's no more uncomfortable than the many worlds interpretation. If you believe that you can exist in the wave function in two different states, in two different places in the wave function, then there's no fundamental difference between that and a cat existing as a live cat in one place in the wave function and a dead cat in another place in the wave function. And then
they're both.
we perhaps want to ask, well, could I exist in the wave function as a live me and a dead me? And that's even more uncomfortable.
I mean, if a cat could, then you certainly could, right? We just swap out you for the cat in the experiment.
There's nothing fundamental preventing that.
Just ethics. Like, I mean, animal experiments, people seem to be more comfortable with. I don't know if anybody's ever going to set this up, but if they did, people seem to really like messing with cats, so they'd probably do it with a cat.
They still can't know, because once you've observed whether the cat's alive or dead,
Right.
once you know, like you can't observe the cat prior to observing it and collapsing the wave function.
Yeah, and I guess the observer appearing two times in the equation brings up the possibility that, well, I guess we kind of already said this, but like that you're in a superposition of two different states, as viewed from outside. Like, so yeah, like we could put a scientist into the room with the cat, and the scientist opens the box and observes whether the cat is alive or dead, and if you still haven't, talked to the scientist about what he observed, then essentially the scientist and the whole system with the cat is still in a superposition of states. And so it almost seems like there's these different realities that people can exist in when they haven't communicated with each other.
Yeah, it's all just the laws of quantum mechanics.
Yeah, that's an interesting one. Like the idea that like it flows outwards. Isn't that kind of like decoherence, like the idea of decoherence?
Yeah, so decoherence is another word that comes up a lot in this subject that we've sort of tangentially touched on, but not by name. But sort of as I was saying earlier, like when you do an experiment where you put some particle in a quantum superposition, you have to be a little careful about it. Well, maybe you have to be a lot careful about it. You have to preserve that superposition by making sure that the particle doesn't interact with something that would sort of in effect cause a measurement, which is essentially what people call decoherence, where you have set up the wave function in some superposition state, and then it interacts with the environment, and as it interacts with the environment, very quickly that state becomes a superposition, without bringing wave function collapse into this, that state becomes a superposition of these very large states that involve very many things, and it's no longer, the reason it's sort of called decoherence is because it's no longer possible for those two different states of the particle to interfere, because they're sort of tangled up with the states of all the things around them. And in order for two states to interfere, they have to really be, states of just that one particle that you want to interfere.
Yeah, this language of entanglement makes me think that all of these particles are like tied together with balls of yarn or something.
Oh no. Well, it seems like it's kind of more what you just described, Chris. Like one way to interpret it could be like that, is if it's like you have like the box and the cat and the scientist, like they're kind of now, I don't know if this would be a way to, I don't know if I'm totally stretching here, but like that's almost like a kind of entanglement. And then once you observe it, then you're also entangled with them, and it's like a chain reaction outwards. I don't know if I'm totally butchering those concepts, but that's what it makes me think of.
Yeah, I mean, I think the thing that causes the information to propagate is sort of repeated measurements. So the scientist measures the cat, and then the other scientist measures that scientist, and then the information of what was observed kind of propagates out. But each time that happens, it's because there's been a new measurement that's occurred.
Yeah, that's one way of looking at it, but we don't really know, I guess, because
and it would be impossible for us to know by the setup itself.
Yeah.
I mean, there is when you ask this question of like when does a measurement occur, you can try and answer that question with a bit more precision than we've explained so far, and that's sort of what the subject of decoherence that's been brought up. That's sort of the question that subject asks is, how much does this quantum superposition have to interact with its environment or with things around it, so that it's no longer possible to recover these interference effects. So you can do a bunch of math and work out when you think that happens, and then you can say. Then you can bring interpretation back into this and say, well, maybe at the point where decoherence has taken place, some kind of collapse of the wave function also has to take place. Or you can say, well, I still believe in the many worlds interpretation, and all of these possibilities are still there, but it's no longer possible to speak of all of them at once and recover interference effects because things have decohered.
Thank you for joining us on the Multiversity. We hope you found this episode both mind-bending and enjoyable.
We can be found all over the social media space and at multiversitypodcast.com.
If you like this content, give us a like, comment, follow, share, or support us on Patreon.
Catch you on the flip side.